Okay, good morning. This is the video for Friday, May 15th, okay, for pre-calculus. I am going to be working on the same sheet from the other day, even more evaluating limits, okay? I'm going to do a bunch of examples, and you're going to have to finish whatever we did not do for homework. So you're going to have to submit the whole thing for homework. So the ones I'm going to be doing, if I did them some of these in the Zoom, that's okay. It's okay for you to see them here as well. Okay, let me just make this a little better. Okay, number 8. The limit as x approaches -1 from the right of x plus 1 over the square root of x plus 1. Okay, so we want to get rid of if you plug in the -1, you get 0 over 0, which we're not allowed to have, right? That's indeterminate. So then the way we get rid of it is multiplying by the same radical. That's how we rationalize the denominator. We multiply by square root of x plus 1 over square root of x plus 1. We end up with a limit as x approaches -1 from the right of x plus 1 times the square root of x plus 1 over, when you multiply a radical by itself, the radical goes away, so it just becomes x plus 1. So then the x plus 1s cancel. At this point, if we plugged in -1 to both, we would still get 0 over 0. Now, when we cancel these, now we're left with the limit as x approaches -1 of the square root of x plus 1. I am now going to plug in, I don't have to write the limit anymore. The square root of -1 plus 1 is the square root of 0, which is 0, which is allowed. Okay, the square root of 0, which is 0, and that is fine. That is the limit of number 8. The next one I'm going to do is number 10. Okay, number 10 is the limit as x approaches 0 of x minus 4 over the square root of x squared, square root of x minus 2. Okay? For this one, when I plug in 0, it works. I get a value, so I'm going to be good to go. So I end up with 0 minus 4 over square root of 0 minus 2. -4 over -2 is just 2. So for that one right there, we're good to go. There's no problem. We're done. That's the answer. Number 11 is the limit as x approaches 1 of x squared minus 1 over the square root of x minus 1. So now here, I plug in 1, I get 0 over 0, indeterminate. I can't have that. So what do I have to do? I'm going to multiply the denominator by the conjugate. Now this is different than this one because there's only one radical here. And when you multiply a radical by itself, the radical goes away. But here, if I multiplied it by square root of x minus 1, I would end up, it would not go away. Okay, I would still have radicals in my answer. But if I multiply by the conjugate, which is the square root of x plus 1, now I have the limit as x approaches 1 of x squared minus 1 times the square root of x plus 1. And over here, when you multiply these both out, you end up with x plus radical x minus radical x minus 1. But the middle terms cancel out when you multiply conjugates. So you don't actually I mean, I can show you this one time, but you don't have to actually do it. You could just do the first ones and the last ones. Square root of x times square root of x is x. Negative 1 times positive 1 is negative 1. If I did do it all out, I would get x plus radical x minus radical x minus 1. And these would cancel, and I'd be left with x minus 1. But with conjugates, I don't usually do that because I know it's just the first and the last. Okay? So, now, we're not done yet. If I plugged in 1 now again, I would get 0 over 0. However, x squared minus 1, we all know that factors into x plus 1, x minus 1. Okay. So now, when we cancel out, and guys, you remember you can pause at any time to catch up. It's all there. When you cancel the x minus 1s, now we have the limit as x approaches 1 of x plus 1 times the square root of x plus 1. And now I plug in the 1, we get 1 plus 1. I don't have to write limit once I plug it in. Square root of 1 plus 1. 1 plus 1 is 2. 1 plus 1 is 2. 2 times 2 is 4. So the answer to number 11 is 4. Okay, we've done 3 problems so far. We're going to do 4 more. Okay. The next one I'm going to do is number 12. Number 12 is the limit as x approaches 1 of x minus 1 over the square root of x squared plus 3 minus 2. The minus 2 is not underneath the radical. Okay, so x, okay, now, if I plug in, hold on one second, I'm missing my sheet, here it is. Okay, if I plug in 1, I end up with 0 over 0, right? 0. Square root 1 squared is 1 plus 3 is 4. Square root of 4 is 2. 2 minus 2 is 0. And that is not what we want. Well, now we're going to do what we did for this one. It just looks a little more challenging because of the values. I'm going to multiply by the conjugate of the denominator, which is the square root of x squared plus 3 plus 2. The square root of x squared plus 3 plus 2. And what happens there, now I've limited as x approaches 1 of, I have in the numerator now I have x minus 1 times the square root of x squared plus 3 plus 2 over, now again, we only have to multiply the first times the first and the last times the last because they're conjugates. When you multiply a radical by itself, the radical goes away. Minus 2 times plus 2 is minus 4. We continue down here. The limit as x approaches 1. Plus 3 minus 4 is minus 1. So now I have x minus 1 times the square root of x squared plus 3 plus 2 over x squared minus 1. If I plugged in 1 still, I would get 0 over 0. Still not good. But this factors to become x plus 1, x minus 1, or x minus 1, x plus 1. The x minus 1s are going to cancel, right? The x minus 1s are going to cancel. Always put little 1s there. And now I'm going to plug in the 1. I need to write it first. I'm going to plug the 1 in. The square root of 1 squared plus 3 plus 2 over 1 plus 1. 1 squared is 1 plus 3 is 4. Square root of 4 is 2. 2 plus 2 is 4. 1 plus 1 is 2. 4 over 2 is 2. So the answer to number 12 is 2. The next one I'm going to do is number 17. Number 17 is the limit as h approaches 0 of the square root of 1 plus h minus 1 over h. If I plug in 0, I get 0 over 0 okay? And I don't want that. Well, here we're going to multiply by the conjugate of the numerator to get rid of these radicals here. So we're going to multiply by the square root of 1 plus h plus 1 over the square root of 1 plus h plus 1 equals the limit as h approaches 0 of, these are conjugates, the first times the first gives us 1 plus h, the last times the last gives us negative 1 over h times the square root of 1 plus h plus 1. Now the numerator is going to become h, because the 1 and the negative 1 are going to cancel, over h times the square root of 1 plus h plus 1. The h's now are going to cancel. Don't forget, you must put a 1 as a placeholder in the numerator. It must be there. You'll get the wrong answer. And now when we plug in, we end up with, we're going to plug in down over here. I'm going to plug in 0, 0 for the h over here. So I'm going to have 1 over the square root of 1 plus 0 plus 1 is 1 over the square root of 1 is 1. Square root of 1 plus 1 is 2. So 17, the answer is 1/2 for number 17. Okay? Next up, number 19. Okay, page. Number 19 is the limit as x approaches negative 4 of 1 over 4 plus 1 over x over 4 plus x. And 4 plus x is the same thing as 4 plus x over 1 or 4 over 1 plus x over 1. Either way, however it's easier for you to write it. So now I'm going to write it as it was 4 plus x. I'm going to make them each over 1. Looks a little easier. I'm going to multiply, if I plug in negative 4, 1/4 plus negative 1/4 is 0. 4 plus negative 4 is 0. I get 0 over 0 and determinant. Now I have that, so what am I going to do? Well, this is called a complex rational expression, fractions within fractions, right? So what I'm going to do is multiply by the lowest common denominator of all the denominators, which is 4x, 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 4x. And what's going to happen is it's going to clear out all the denominators. So the 4 and the 4 are going to cancel. The x and the x are going to cancel. So it's going to be the limit as x approaches negative 4 of x plus 4 over 16x plus 4x squared. Okay. It might have been easier just to do 4 plus x times 4x. You know what? well, this does work, but there's a little extra work I just did here right now. Sorry about that. Because when I factor this out, it becomes 4x over 4 plus x. So that was an unnecessary step. I could have left this as 4x times 4 plus x. So if I were to do that again, that's what I would have done. And that would have been easier. But it worked. It's nothing wrong. It's just a few extra steps. Anyway, the 4 plus x goes into x plus 4 one time. We're left with 1 over 4x. So I'm going to do 1 over 4 times negative 4 is 1 over negative 16, or negative 1 over 16. Okay, so that was the answer to number 19. Again, so if I would have just left this together as 4 plus x and then multiplied by 4x, I would have gone from here directly to here, 4x times 4 plus x, and I would have skipped this part. This part was not necessary. I would go from here to there. And the last one we're going to be doing is number 22. Number 22. The limit as x approaches 0 of 5 plus x raised to the negative 1 minus 5 to the negative 1 over x. So if I plug in 0, I have 0 and it's undefined. Okay, so I want to rewrite this. I'm going to rewrite this as the limit as x approaches 0 of, when you have to the raised to the negative 1, you do 1 over it. 1 over 5 plus x minus 1 over 5 all over x. And x is the same thing as x over 1. The lowest common denominator of all the denominators is 5 times 5 plus x. 5 times 5 plus x. 5 times 5 plus x. The 5 plus x's cancel here and here. The 5's cancel here and here. So what we are left with is the limit as x approaches 0 of 5 minus parentheses 5 plus x over 5x times 5 plus x. When you distribute the negative sign here, it becomes 5 minus x. The 5 minus 5 cancels, so you actually end up with negative x over 5x times 5 plus x. The x's cancel to become negative 1. So we have negative 1 over 5 plus x, negative 1 over 5 plus 5 times 5 plus x, negative 1 over 5 times 5 plus 0 is negative 1 over 25. Negative 1 over 5 times 5 plus 0, because here we had, they canceled out. So negative 1 over 5 times 5 plus 0 is negative 1 over 25. Okay, so we just did 7 problems, 7 good practice problems on limits on the page called Even More Evaluating Limits, okay? Your homework is to complete the sheet. So all the ones that we did not do, you need to do. So that's from that's the assignment for today. Hope you're all doing well. This will be due on Monday morning. No, excuse me, it's Sunday night. Sorry about that. This is due on Sunday. So today's Friday. You have Friday, Saturday, Sunday night up to 11:59. Okay, everyone, be good. Have a good day. Stay safe.